Welcome to Lesson 8.5, Algebra 2. We get to explore the exciting world of adding and subtracting rational expressions. Nothing's better than adding and subtracting fractions, except that you get to factor and FOIL and cancel. This is going to be a great lesson. Let's talk about 6 steps that we're going to take before we begin the problems. Step number 1. You're going to factor just the denominators. When we're dealing with adding and subtracting, we're going to look at numerators and denominators separate. So start just with the denominators. Step number 2. Find a common denominator. If you want to go back a moment to just adding fractions in general, if we were to add 7 over 16 with 3/4, in order to add those two fractions, you need a common denominator. So I would multiply one of these by 4, both to the denominator and the numerator. And when you write your answer, the 16 carries over. Not 16 plus 16, just 16. In the numerator, the 7 and the 12 will be added together. It's going to be similar for us when we're working with binomials and trinomials. So come up with that common denominator. What we need to do extra is to state our restrictions. When you do your restrictions, it's going to be of that common denominator. Add or subtract the numerator, just like we did up here with that 7 plus 12. The denominator is not going to change. That common denominator will be carried throughout the problem. Once you've added or subtracted the numerator, you get to factor the numerator and then simplify anything that you can. So let's give it a try. In our first example, when I look at the two denominators, and I go to factor, y squared minus 5 cannot be factored. This is not a difference of two squares. If I try to take the square root of 5, that's not a whole number. So there's nothing to factor in the denominator. They are already common. They're both exactly the same. So steps 1 and 2 are already taken care of. I'm going to bring my denominator over. Y squared minus 5. Come up with the restrictions. Again, just focus on the denominator. Y squared minus 5 cannot equal 0. Add the 5 across. Y squared cannot be 5. Get rid of the square by taking the square root. Therefore, y cannot equal the square root of 5. And when you take a square root, it'll be both the positive and the negative that y can't equal. And that's only because we took a square root. All right, moving on now to the numerator. Bring these together. 6y minus 4 plus 3y plus 1. Add the numerator by combining like terms. I have 6y plus 3y and negative 4 plus 1 all over y squared minus 5. Go ahead and factor the numerator if possible. This time I look and I can see it has a GCF of 3. So I'm going to divide the 3 out of the numerator. Divided by y squared minus 5, where y cannot equal plus or minus radical 5. This time nothing could simplify, so you could have left your answer as 9y minus 3, but I still want you to factor. How do you know if you can cancel if you don't factor? So go ahead and factor it and then just leave this as your answer. Let's try a problem now where you don't have a common denominator. Right, step number 1, factor. I can see I have a trinomial. What multiplies to give me 4 and adds to give me 4? That'll be 2 plus 2 and 2 times 2. So this denominator is x plus 2 times x plus 2 all over x plus 2 plus this x plus 2 on this side. I can't factor. I'm just going to rewrite it. These are my two fractions. It might help you visualize if you put a wall between them. I need the two sides to be exactly the same. When I come up with a common denominator, I'm going to circle what is exactly the same already. I have an x plus 2 on both sides. So I'm going to write that one down. Now what's left over? Everything in your denominator needs to be circled. Everything has to be accounted for. I can see on this side is another x plus 2. So I need this second one also on the right-hand side. I'm going to put x plus 2 there. And if I put it in the denominator, I also put it in the numerator. And this is 2 times the x plus 2. Now I've accounted for every binomial in the denominator. All right, let's write out our numerator. I have x plus 2 plus, right here, 2 times x plus 2. Okay, before I move forward, let's do our restrictions. Denominator tells me that x cannot be equal to negative 2. All right, before I add and subtract the numerator, I need to take care of this 2 times x plus 2. So let's distribute. I have x plus 2 plus, this is my 2x, 2 times 2 gives me the 4, all over x plus 2 times x plus 2. Combine like terms. X plus 2x is 3x. 2 plus 4 is 6. All over x plus 2 times x plus 2. Now we get to factor the numerator. 3x plus 6 has a greatest common factor of 3. So let's divide both of those by 3. The 3x gives me just x, and the 6 gives me 2. I have 3 times x plus 2 all over x plus 2 times x plus 2. Finally, we get to simplify, reduce this fraction, and my final answer is 3 over x plus 2, where x cannot equal negative 2. Let's try one more of those together. On letter C, I want you to push pause and go ahead and factor what you can, and then we'll come up with a common denominator together. All right, I went through and factored everything that I could, and you can look back at it. So I'm going to begin down here where I'm already in factored form. I need to come up with a common denominator. So I'm going to circle what the two fractions already have in common. They both have this x plus 5. If that's common, I'm going to put it in my common denominator. Now I need to account for the things they are missing. The second fraction is missing the x plus or x minus 5 portion. You can think of it as cross multiplying. I need to start here at the bottom, cross over to the numerator, and multiply. Whatever I multiply to the numerator, I also put in the denominator. So I've now accounted for that x minus 5. The only thing now not circled or underlined is the x plus 1. So let's take care of it. The x plus 1 needs to cross over from denominator to the other numerator and multiply. If I multiply the top by it, I multiply the bottom. I've now accounted for the x plus 1, so it goes in my common denominator. Now as you look across the denominators, they're all exactly the same. All right, go ahead and come up with what your restrictions are. I have that x cannot equal negative 5 from the blue, positive 5 from the green, and negative 1 from the purple. Now let's look at our numerator. I have 4 times x plus 1. Let's go ahead and distribute. That'll be 4x plus 4 plus, way back here is a plus sign, 6x, because I'm going to multiply, minus 30. 6 times negative 5. And we're almost done. Simplify by combining like terms. So 4 plus 6 gives me 10x. 4 minus 30 is negative 26. And then rewrite your denominator. X plus 5, x minus 5, and x plus 1. The last thing, go ahead and factor the numerator. They each have a GCF of 2. So if I factor the 2 out, I get 5x minus 13 divided by x plus 5, x minus 5, x plus 1. Nothing can be reduced. So I've got my restrictions, and I have my final answer. But again, you don't know if anything can be reduced unless you factor and look at it. That concludes part 1, where we are adding rational expressions. In part 2, we're going to subtract. In part 3, we're going to work with complex fractions.